Good day everyone and welcome back to our channel. This is Liceo Math Club's current Executive Secretary, Gabrielle Abella, and today I will be presenting to you how to compute the mean and variance of a discrete random variable. First off, we should define terms. I will not be dwelling long on what a random variable and a discrete random variable is, since this topic has been discussed in previous tutorials. So in summary, a random variable is a quantity whose value is random and to which a probability distribution is assigned, such as the possible outcome of a roll of a die. Meanwhile, a discrete random variable is a type of random variable which is obtained by counting values for which there are no in-between values, such as the integers 0, 1, 2, and so on. Now let's talk about the mean. A lot of you may be familiar with the word mean or average, and it is quite similar with what we are going to talk about today. So a mean, in probability, is a weighted average of the possible values that the random variable can take. It is also called as the expected value. In probability, this is the symbol for mean and can be read as mu. The formula in solving for the mean of a discrete random variable when provided with a probability distribution is the summation of the product of the possible value of the random variable and the probability that the random variable will happen, or in short, the summation of the product of x and p. So let's try an example. In a recent league softball game, each player went to bat 4 times. The number of hits made by each player is described by the following probability distribution. So this is the discrete probability distribution, which is already given in the problem. On the left column is the possible values for the random variable x, which is the number of hits, and the right is the probability that that is going to happen, or p of x. Now let us solve for the expected value. Solving for the mean or expected value. Following the formula, which is again the summation of the product of x and p, or p of x, multiply every possible random variable value to the probability that it is going to happen. So 0 multiplied by 0.1 plus 1 multiplied by 0.2 plus 2 times 0.3 and so on. If you have a calculator with you right now, you will get the answer right away, which is 2.15. This means that the average number of hits made by each player in that league softball game is 2.15. Always remember that the expected value doesn't have to be one of the values of x, since it is just an average value. Now let's talk about variance and standard deviation. Another feature of a random variable's probability distribution that we want to examine is variability. So a variance is used to measure the spread or variability of the distribution. Variability is a term that refers to the characteristic of dispersing from the mean or average of the random variable. So variance is denoted by this symbol, which is read as sigma squared, and its formula is the summation of the square of the possible value of the random variable subtracted by the expected value times the probability of that value happening. In other words, variance is equal to the summation of random variable x minus mu, or the mean, squared times p. The standard deviation, meanwhile, is the square root of the variance and is denoted by the symbol sigma. So let's try the same example. Solving for the variance and standard deviation. From the formula, the value of the mean is needed in order to solve for the variance. Hence, that is why 2.15 is located here for reference. Now let us start substituting the values from the probability distribution to the formula. Sigma squared is equal to 0 minus the mean, which is 2.15 squared, times 0.1 plus 1 minus 2.15 squared times 0.2 plus 2 minus 2.15 squared times 0.3, and so on and so forth until you reach the end of the probability distribution. Now enter these values to a calculator and we get 1.4275, which is the variance. On the other hand, in order to get the standard deviation, just simply get the square root of this value. From this, we get this value, or when rounded off, we get 1.195 as our standard deviation. Now basing from the variance, the variability of this distribution is 1.4275. Let's practice more. You can pause the video if you want to answer in advance and check your answers from the remaining slides. Make sure to have your calculator beside you. For our first example, an easy one. Calculate the mean, variance, and standard deviation for a random variable, x defined as the number of tails in 4 tosses of a coin. The probability distribution is already given. By the way, for all our examples, the probability distribution will already be given since the next tutorials will be the one to focus on how to solve these probability distributions. So anyway, the random variable is the number of tails in 4 tosses of a coin, and on the left side of the table it shows the possible values for the random variable, and for the right side is the probability that these respective values will happen. Solving for the mean. This is really easy. You just need to substitute the values to the formula as what we have learned earlier. So 0 times 1 over 16 plus 1 times 1/4 plus 2 times 2/8 plus 3 times 1/4 plus 4 times 1 over 16. Mean is equal to 2, which means the average number of tails in 4 tosses of a coin is 2. Solving for the variance and standard deviation. Based from the previous slide, the mean is 2. So together with the values from the table and the mean, let's substitute these to the variance formula. 0 minus 2 squared times 1 over 16 plus 1 minus 2 squared times 1/4 and so on. The variance now is 1. Hence, square root of 1 is also equal to 1, which makes our standard deviation also 1. Our next example, the function in the given table is a probability function of a discrete random variable x. Calculate the mean and variance of random variable x. As you can see in the table, there is the presence of a literal coefficient, which is a, and which is what we need to get rid of first. Now since we are given this type of problem, we need to solve for a first, before getting the expected value and variance. Note that the values on the right are the probability for the values on the left to happen, which means that the probability that x will be equal to 1 is 10 over 27 and so on. We know that the sum of these probabilities is equal to 1, so we equate the values on the right to 1. This leads us to 10 over 27 plus 8a plus 6a plus 1 over 9 is equal to 1. Solving this equation, transpose all the constants to the right side and simplify. We get 14a is equal to 14 over 27. And then simplify again, we get the value of a, which is 1 over 27. With this, 8a is now 8 over 27 and 6a is now equal to 6 over 27. Now since we have the values, it will be easier to solve for the mean and variance as this will only require substitution. Substitute the values in this formula and we get the mean or expected value, which is 76 over 27 or 2.81. Now substitute the values to the variance formula and we get the variability of this probability distribution, which is 2.67. Our last example is kind of complicated. Mr. Velez works as a part-time lecturer in two universities, namely University X and University Y. Next academic school year, he will get a raise in his hourly rate of X pesos from University X and a raise in his hourly rate of Y pesos from University Y. The increase in hourly rate in both universities depend on several factors, and thus can be regarded as random variables. Suppose that X and Y are independent random variables with probability mass functions, respectively these two tables below. These are types of problems that have more than one random variables, increase in hourly rate X and increase in hourly rate Y, which are both independent, and also with independent probability distributions. So let us try solving step by step. Always remember that given two random variables X and Y, the expected value of the sum of X and Y is equal to the sum of the individual expected values. So we need to solve for the mean of the probability distributions first individually. For the first table, substitute all the values to the mean formula like how we used to do from the past examples. Mean is equal to 20 times 0.2 plus 30 times 0.4 plus 40 times 0.3 plus 50 times 0.1. Press enter on your calculator and you get 33. For the second table, do the same. Substitute the values and we get the mean, which is equal to 49. Lastly, we need to add these both values in order to know what Mr. Velez's expected total raise in hourly rate from both universities is. Mean of X, which is 33, plus mean of Y, which is 49, is equal to 82. Therefore, Mr. Velez can expect a total raise in hourly rate from the two universities of 82 pesos. Solving for the variance is similar from what we did with the mean. Given two random variables X and Y that are independent, the variance of the sum of X and Y is equal to the sum of individual variances. So like what we did with the mean, we will also solve for the variance individually first. For the first table X, the mean is 33. So substitute the mean together with the values in the table to the variance formula. Sigma squared X is equal to 20 minus 33 squared times 0.2 plus 30 minus 33 squared times 0.4 and so on. The answer from the calculator will be 81. Now let's move on to the second table. The mean is 49. Using this, substitute it along with the values in the second table to the variance formula. Sigma squared Y is equal to 30 minus 49 squared times 0.3 plus 50 minus 49 squared times 0.5 plus 75 minus 49 squared times 0.2. The answer is equal to 244. Again, just like the mean, we add the two individual variances together to know the actual variance of the total raise in hourly rate for both universities. The variance of both, 81 plus 244, is equal to 325. Lastly, solving for the standard deviation, we get the square root of 325, which is 5 square root of 13 or 18.03 in decimal form, which means the standard deviation of the total raise in hourly rate for both universities is 18.03 pesos. And that's all for today. Again, this was Gabrielle and Abella. Thank you so much for listening. Please don't forget to like, comment, and subscribe if you like the video.